Good everyone, and welcome back to another edition of this data analysis training. Today we'll be talking about the descriptive statistics in SPSS. And descriptive statistics are basically of two types. We have the qualitative data analysis and we have the quantitative data analysis. And while the qualitative data analysis specifies on two data types, which are the ordinal data type and the nominal data type. So what do I mean by ordinal data type? Ordinal data type in SPSS as basically grouping based on factors or arrangements. For example, low, medium and high, rich and poor, male and female. And we have the nominal data type, which there is no specific ordering, but it is also based on grouping. For example, accountants, and for example, jobs, let's say doctor, farmers and teachers. They are trying to like group people into their occupations. So or job roles in a company like employee, cleaner, farmer. So that is a layman definition of an ordinal and a nominal data type. So this qualitative data type is basically analyzed using a frequency distribution table or visualized using a bar chart or a pie chart. And you have the quantitative data analysis, which is basically integers, floating numbers and ordinal and decimal numbers. So they are basically numbers. I know that there are different type of numbers. We have a ratio, integer, like I said, floating, and other number types, data types we have in the field of statistics. So what is now descriptive statistics? Descriptive statistics is basically a way to like summarize your data sets, which can either be an aggregation or a grouping. So it's basically a way to like provide a brief summary of our data sets. And we've already talked about data types involved. Now we're talking about the descriptive statistics process basically. So moving on, I believe we've all known the data types in Excel and SQL. Okay, I believe we all know the data types in SPSS already and how to input them. On the first video talking about the introduction to SPSS, it already covered the basic data type in SPSS and how to insert data in Excel in SPSS. So basically you've already known the importance of each and every one of these labels, already understood the variable view and data view, so I don't have to go back to it already. So first we are going to be talking about the quantitative descriptive statistics. And like I said earlier, descriptive statistics basically provides an aggregation and a brief summary of like our data sets. So moving on, to create a descriptive statistics in SPSS, you go to analyze, right? Then descriptive statistics. Now you'll be presented with this tab, but we'll be focusing mainly on these three: frequency, descriptive, and explore. This first tab is basically for qualitative data sets as well, but based on two qualitative variables. So it can be on an ordinal and a nominal data, or two ordinal data or two nominal data sets. So you also have then we have the frequency analysis, which is basically for qualitative data sets, because it's like a frequency table, and we know that frequency table is a categorical table. So we'll get into that as well. They move to descriptive statistics, which the descriptive section, which is basically like the quickest among the theory. And what it does is basically for quantitative data sets, and it provides a quick summary of the data sets. They move to explore section allows us to further our research more on the quantitative descriptive statistics as well. So what does? It allows us to like provide a quick summary of our data set, as well as checking the distribution of the data set, checking for the outliers, and checking for the extreme values as well. So, and considering the outliers, outliers are values that are unusual in the data set. For example, let's say we have numbers ranging from 1 to 10. We now, our next value was now 100. Now, looking at the older datas, you can see that this 100 is unusual. Or let me make a very realistic example. Let's say the grades of some particular students, and let's say 35% of the students are actually getting like 70 to 100 and above. Then we have like 20 percentage of the students getting below 40 or below 30. You can see that those values are kind of odd compared to the rest of the students, so they are regarded as an outliers, which in a statistics sense, the the client or the manager, we have to look into those people, because either they are not like being attentive, or the teachers are not focusing on those students when teaching them. So they are the outliers. So that's what Explore does. It allows us to like further our research on the quantitative descriptive statistics. So if you ask me, the best one for quantitative descriptive statistics is the Explore, basically, because it allows us to further more. Or let's say you just want a quick summary of the data sets. For quantitative, then go for descriptives. But for qualitative, go for Explore. And for the frequency, for qualitative, frequency. But if you have two qualitative data sets, go for the crosstab section. So I think I've briefed us on these four sections. So I'll also be sending a slide to us talking more about this descriptive statistics, so we will better understand, in case if this video was not clear at the first watch. So moving on, start with the quantitative. Like I said, click on descriptive statistics. So I've already clicked on this particular. I chose income and wireless over tenure, so I expect us to do the same too when watching this video, so you can better understand what I'm doing. I will also tell you why I did it, because like I said, quantitative data set is based on numbers, and when you check the data sets I chose, the variables I chose rather, you can see that, for example, household income that I chose is yes, this is in scale, and this scale is representing a continuous data set, unlike this nominal and nominal that is indicating qualitative data sets, which is basically indicating that the only analysis we can conduct when it comes to the descriptive statistics is the qualitative data analysis. So in short, any variable denoted with this icon looking like a ruler is indicating a scale, which means that you can use a quantitative data analysis for it. So moving on, click on OK. So you can see that's the minimum value of 0 and maximum value of 12,358. This is the average value. This is the standard deviation. And what does standard deviation indicate? Standard deviation basically talks about the spread of our data sets. And what do I mean by that? Let's say we have 10 data sets, right, which is ranging from 1 to 10. So you can choose from 1 to 10, and we have another data sets indicating that you can choose from 1 to 100. And let's say moving to the first data set, I said that you can choose from 1 to 10. The values are in this format. Let's say 1, 2, 3, 4 up to 10. But the second one, the data are like 1, 10, 50, 100, 180, and so on and so forth. You will see that this first one we have a lower standard deviation, and the second one we have a higher standard deviation, which is indicating that the higher the distance between the first and the second one, the higher the spread. So that's what standard deviation and variance indicates. Basically, it's indicating that the higher the spread, like the higher the values are in between them, the higher the standard deviation and the variance. So that's what the variance and standard deviation actually does. It allows us to measure the distribution of our data sets, the spread. So moving on, this skewness and kurtosis basically allows us to check for the distribution of our data sets. This standard error is also used for calculating standard deviation in statistical aspects. So this skewness is basically divided into a lot of things. we have the left skewness, we have the right skewness, and we have the normal distribution, which is the bell curve. So all these are statistics, and I don't feel I should go further into it, because if you're not a statistics student, you might not be able to relate. This kurtosis is basically a measurement of the like shape of the bell of the normal distribution. So the higher the we have a platycortic, we have the leptocortic, and we have the mesocortic. The mesocortic is the normal shape of the normal distribution of a data set. So I don't know, these are statistics, and I don't feel like I should be talking further on it. If you want to learn more on skewness and kurtosis, I would advise you make a research on it. So, but before you make a research on it, first of all, I have to understand what we mean by normal distribution, so you not get confused. So moving on, we move to the the explore section, allowing us to further our research using these two quantitative variables as well. So moving on, we go to the same analyze, and mind you, this is a shortcut on SPSS. This particular icon allows you to like click on your previous activities on the analytic tools. So like we are doing earlier, I'll go to the descriptive statistics, then go to explore your two variables. So what this factor list is indicating is that, let's say you have a categorical variable, or let me say in this situation a qualitative variable. So like for example gender, it's going to split the quantitative variables into based on the factors variable. For example, it's going to be giving us two values instead. It's going to be giving us for male and female instead of just giving us a plain value. So let's do it. Wireless over tenure and the household income. So because of the large amount of data present in this particular data and this particular data set, is going to make the variables hard to find. So this is it. Then our factor variable is going to be gender. I just want to show us what I mean. Then go to the statistics, click on descriptive statistics. So it's going to give us all these old values we got in earlier. Like I said, you can click on outliers as well. Then go to plots. I don't want a stem and leaf plot. I want an histogram showing us the distribution of our data sets. I want a normality plot with tests. Test of normality, basically it's going to give us a Shapiro weak test, and it's going to give us a Kolmogorov-Smirnov test. So doing the option, okay, yes, and I want both the statistics and the plot. So moving on, click on continue. So it's going to give us the syntax as well, like it's still loading. So it's still processing. So as you can see, this is our values. This is the value we got earlier. Okay, this is the case processing summary. You can see that it has been splitted for both particular genders. So you can see that the household income is now in male and female. If you add these two values together, you are going to get this 4,999 that we got earlier. You can see that 8 plus 1 is 9, 4 plus 5 is 9, 4 plus 5 is 9, 2 plus 2 is 4, getting this value. And as for household income, so this is the histogram, so showing the distribution of our data sets. Basically is basically applied for normal distribution. So we are applying for the distribution curve as well. So you can see that this data set is left skewed. It's skewed to the left, indicating that majority of our values are below 400 for the male category. Yeah. Yes. Okay. So you can see that the minimum is 9. The minimum value is 9 here, and the maximum is 1073. I actually wanted to check to see if I'm actually correlating with the output. So you can see that majority of our values here are below Okay, they're actually more. Yes, like I said, this is the 1000, and this is our maximum value, 1000 and something that we got earlier. You can see it here. I don't know if you can see it, but it's very very tiny, and you can also see a value very close to 1000. You can see a value close to 800. So there are values here actually, but majority of them, let's say 65% of our values are actually present here. That's what I'm saying. It is left skewed, and you can see that majority of our histogram is like majority of our values are actually higher. Yeah, you can see that close to, let's say, 8,825 people have this particular value of let's say 50. So and when same goes for the ladies as well, it's followed the same pattern. So then we basically don't need this, but this is also basically showing the distribution of our data set. So this is the outliers. Obviously there are so many outliers, as you can see here. Basically the goal of everything, the goal of what the outliers and what the box plot, which is showing the outliers, and the distribution curve basically is trying to do is basically trying to make our data set to be normally distributed. A normally distributed data set is basically mean that the distribution is evenly distributed. Like let's say we have data value of 100, the data sets are evenly distributed. That means we have almost equal number of values below 50, and below 50, and we have equal number of values or slightly equal number of values above 50, for example. At least that's a fair layman way to explain it. So then moving on, then we have the test of normality. So basically what this Shapiro-Wilks test and this Kolmogorov-Smirnov test is basically indicating is that if a value is less than 0.05, which is a statistical cut point, it's called a critical value basically in statistics. So if your value is less than 0.05, you have to reject, the null hypothesis, which is stating that your data is normally distributed. And if your data set is above 0.05, you have to accept the null hypothesis, which is indicating that your data, okay, I think I made a mistake there. If your value, your p-value or significance value is greater than 0.05, you have to accept you have to accept the null hypothesis, indicating that your data set is actually normally distributed. And if your significance value or p-value is less than 0.05, we have to reject null hypothesis, and you have to conclude that your data set is not normally distributed in the population. Then moving on, we talk about the qualitative data set, where that's where the frequency distribution comes into play. So click on the frequencies. So the two data sets that we're using to test household income and okay, yes. So we want frequency distribution tables, obviously. Okay, no, we cannot use this because, like I said, it is for qualitative data sets, and these are scale, which indicating that is a continuous value. But we want to group in actually, let's say age and categories. Okay, let's say, yeah, age, or let's use gender and size of, okay, and this geographic indicator, right, yeah, geographic indicator. So we go to charts. I want a bar chart getting the frequency, yeah. Then go to statistics. Since it's a qualitative data set, we don't need all these ones because you cannot calculate the frequency of, let's say, you cannot calculate the frequency of gender, for example. When we know that gender is either male or female, how do you want to calculate the average value? Instead, if we count those genders, which is a different thing entirely. This one is not counting. It's not like counting those genders in that particular way that we want. Like if you use a frequency, if you use this SPSS frequency table to like do the gender calculation, it's not going to get the accurate value. So it's not, you cannot use this particular way, this particular method. So okay, then click on OK. So you can see the same value, the same male and female values. So, and you can see we have 5 different zones. So yeah, so that's all you need to know about descriptive statistics. So if you have any question, you can let me know via my WhatsApp. Thank you very much for watching and have a wonderful day.